Right, today I want to talk to you about modular synthesizers. Just let a few more people in. Okay, so that's what I want. So talking about modular synthesis, and if we get time, we're going to look at how we can do this in software, and then if we get time, we're going to jump into a bit of hardware. So is it that camera here? I've got some hardware here in my studio, so we might have a play with that. But we need to cover some. We need to cover some basics today, and this is very applicable to what you do in Ableton as well, because a lot of the terminology that we talk about today directly affects what you do in Ableton. So understanding certain concepts today is going to help you with Ableton. Right, so let's get started. I think I've done everything. I am recording. Something is beeping away. I don't know what that is. I have stereo on, even though we don't really need stereo in this particular lecture. And that's on. Right, so let's see what we've got. So some things I want to talk to you about today. A bit of a background to modular synths. Looking at semi-modular systems, eurorack, VCV, and then if we've got time, we'll jump into a real eurorack system. All right, so what's modular synthesis? It's basically like modular plugins where we've got this particular modular does this task and this modular does another task, and you chain them all up together and you get some sounds out. All right, and you've got a lot of control over it. And there's lots of different types of systems. So we've got Robert Moog back in the 1970s developed some incredible equipment experimenting with sound. You've already seen some of this equipment maybe on the Dead Mouse stuff. This is all 1/4 inch, old traditional. I've actually fired one of these simulators up in Ableton, I think in one of the first classes that we did. This is huge, this device, absolutely massive. And this is the Mini Moog around 1917. This is something called a Semi-Modular System, which I'll go into in just a minute. This is very popular. In fact, it was re-released not too long ago. Dead Mouse is using the 1/4 inch system, which you will have seen in his videos. But now the real popular sort of modular system is something called eurorack, and we've dropped down from the 1/4 inch down to the 3.5 millimeter jacks, and yeah, it's fantastic. It's often called eurocrack because it's quite addictive once you get into it. It's also very expensive, and it's grown significantly in popularity in the last sort of five years or so. So on the left here, we've got what I would call like a conventional synthesizer. So this is what you might do if you went down to guitar, went into their synth section. That's the sort of thing that you would get. It's self-contained, it's all pre-wired. You literally turn it on and it will play, and you can choose maybe different instrument sounds, etc. But if there's something you don't like, you can't swap it out. So if there was a filter in there that you didn't like, you couldn't swap it out. So the next thing is something called a semi-modular system, which you can still turn it on and play it, but you've got a lot more control over it. And you see you've got a patch bay here on the right. So you can actually start to, the routing is all pre-wired, but you can break it. You can put cables in and reroute it. So you've got a lot more flexibility. And in fact, I don't know does that camera work? No. That camera? Okay. So if I just move this camera down here, that there is a semi-modular, that's a semi-modular system, which is called a Rack Brute 2S. So you can see this here is sort of the main analog engine. Here you've got a sequencer, and then up here you've got where you can route it with these 3.5 mil cables. right? And I could potentially mount it up into this modular system that's here, which we're now going to talk about. So the classic modular synth is where you've got, as I said at the beginning, everything is an individual component. So you've got a module to generate sound, you've got a module to do filtering, you've got a modular to do EQ, and you patch it, which is what, if you watch I can't remember if Danny started the Dead Mouse yet, the masterclass, but you can see him walking around patching things. He's taking one signal from one place and putting it into another place. And that's how we generate our sound. Right, it's extremely expensive. The hardware is expensive, as you can imagine, but we can simulate it all in software using VCV Rack, which is what I would like you all to have a play with. So you can go to vcvrack.com and you can download it. And then if you click on Available Now, and then get Rack 2, and then choose your download. All right, simple as that. And once you've installed it, you'll get something that looks like this. Now, it might be that you've got a load of plugins all up on the screen. So just, if you're following me, if you're following my tutorial, right, you're not going to remember all this because we're going to cover quite a lot of stuff today. That's if I can remember it all. It's best just to start with a blank slate. So elastic band it, press delete. Right, so let's start from the beginning, and then if you watch this back, you'll be able to keep pausing it and making sure that you've got the same that I've got on the screen. Right, the rack that you're looking at is basically supposed to be the same as this rack here. It's just, I've got lots of units in here. So you see these rails? These are the rails that you're seeing here, right? So I can mount my different modules. Okay, remember this isn't Ableton. This is completely different software, but a lot of the stuff that we're learning can be applied to Ableton. And this is a nice way that you can play with modular, see if you like it, and if you like it, then you might want to investigate it. Right, if you right click, so delete anything that's already in there by elastic banding it, then right click and you'll see all the modules, right? You might not have all these because these are ones that I've downloaded, but if you click on brand and go to VCV, that's probably what you're going to see, something like that. Now, if you remember back to our sort of sound basics at the very beginning, we need something to generate a sound. We need some sort of oscillation, an oscillator, and that is something called a voltage controlled oscillator. So here we go. I've just added a voltage controlled oscillator. You press if you use your wheelie button on your mouse, you can go up and down. If you press the control key, you can go in and out. All right, so there's my voltage controlled oscillator. And what I'm going to add next is right click. I'm going to add a scope, an oscilloscope. There we go. So let's take that scope. And what else am I going to want? I'm going to want a mixer, VCA mix. There's a mixer here. So I've got my mixer. I'm going to put that there. And what I'm going to do is I'm going to take my sine wave, a sine wave. By the way, the black ones are outputs. If you've got a black rectangle around it, it's an output. So I'm going to take a sine wave. I'm going to go into my mixer. This just means I can mix different sounds together, which hopefully I'll do later. And I'm going to take the mix out and I'm going to put it into my input. And then I'm just going to zoom in a bit. And like a normal oscilloscope, I'm just going to hit the trigger and there's my signal. I can't hear anything yet. Now, if I want to hear something, I need to add an audio plugin. So I think it's that one there. Right, now I need to select you'll need to select your sound card. got quite a lot here, so I'm going to try that one. Cancel that. Can you guys still hear me? Because I might just have upset something in Zoom. Just give me a thumbs up if you can still hear my voice. Okay, thanks. Right, so the next thing I'm going to do is I want to take this mix, which is this sine wave, and put it into my audio card. And then hopefully you can hear it. So I'm going to press the control key, because if I press just the mouse, I'm going to move this one. But I want to take another output from my mix and put it into one. And hopefully you've got it in your left ear. And if I take another one, control key down, oh, in my right ear. Okay, can you guys hear that? Thumbs up? Right, fantastic. Right, I'm just going to delete those again, because that's what you would do. But because I'm doing because I'm trying to teach you stuff as well, I'm just going to put a VCA, which is like an amplifier in. And I'm just going to press the control key, shift down, and go to there. And then I'm going to take my output and go in here. And what that means is I can just control the volume, but still have the signal. So I can talk to you without you going absolutely crazy, because I'm putting a sine or a square wave into your headphones. Right. Excuse me. Right, if you remember back to the basics at the beginning, if I change the frequency, it changes the pitch and the wavelength. And if I change the amplitude, if you double click, it will reset it to its default values. And that is, have a look up there. Okay, so that's something like 260 hertz or whatever middle C is. You can recognize that note. That's because it's double clicked here. Oh, the other thing about digital, of course, is you don't need to tune it. When I fire up my analog system, you'll see that it all needs tuning. Right, so amplitude is my volume. Okay, it's the amplitude of the wave. Okay, right. So let me just talk to you. Let me just fire up that. There we go. So we've got these. In fact, we can stop doing that one now. So the next thing I want to do is just talk to you a little bit about different types of sound waves. So this is in fact, what would be useful is to see in the frequency domain. So this is in the time domain, but what I want to do is look in the frequency domain. So there's another plugin, which the problem is I can't remember which company makes it. I could go through these one by one, or I could just guess. No. Valfaco doesn't make it. There we go. That's what I'd like. Okay, so this just allows me to look at this sound in the frequency domain. So this is in the time domain. So I'm going to take another signal from here in the mix and just go into here. Okay, and what I can do now is I can see that note. And if I just set the quality's already at good. So this is the middle C note that we're listening to now. And if I change the frequency, this one is going to, the wavelength is going to change, but here it's going to shift to the right because we're moving from 20 hertz on the left up to 20 kilohertz on the right. And this first sort of notch that you see here is called the fundamental, and that's really the note that we're looking at. Now, if this was a pure sine wave, so if we did this in Ableton and used one of the instruments to make a pure sine wave, you wouldn't have any of these sort of aftertones here. You just have this single pure note, but because it's simulating analog, we're getting this extra characteristics of the sound. Now, another sound wave, if I drag this out and put it into square, right, you're getting a very different sound. You're getting a lot more harmonics. And these are all sort of partial tones. These harmonics occur in whole odd number multiples of the fundamental frequency, whatever this first one is here. And if I jump to my triangle, it's kind of a mixture of the sine wave and the square wave. So it's a bit more gentle. And then we've got the saw wave, and the saw wave is sort of the richest harmonically of, saw wave is the richest harmonically of all of them, which is good if we want to do some sort of chiseling of the sound and use something like a filter to take certain sounds out. In fact, let's do that now. Let's have a look. So if I go back to VCV and look for filter, VCF is a filter. So I'm going to take that, let's have a look. So that's going into the scope, and that's going in there. What I'm actually going to do is I'm going to take my saw wave and go straight into the filter here. And then I'm going to take that one out here, put it in here. So now what I've done is I've put the filter in between. So if I open this up, just turn the volume up a bit for you. You can see how we can alter this sound with the filter. Well, let's just keep that filter right open and just turn the volume down here. Right, so already we've spoken about quite a few different modules. We looked about VCO, which is a voltage controlled oscillator, VCF, which is our filter. Think back to your auto filter that you've got, and you've got that analog plugin in Ableton, which has got two voltage controlled oscillators, which is what this is here. And then we've got our scope, etc. Right, if this was real hardware, you've already spent several £100. So you can see how good it is to be able to do this. Right, let's look at how I could get my keyboard working. So if I get another plugin, it's called something like MIDI to CV. CV stands for control voltage. And what I'm going to do is, my keyboard is on, but is it going to work? That's the question. So let's take that, which is one of my keyboards, and then let's take the voltage per octave out, because we use 1 voltage per octave, because everything's voltage, remember, in modular. And let's put that voltage octave out and stick it into voltage octave in my VCO. Let's just drag this down here. So if that's working there, but I can't hear it, but that's because I've... Right, so I'm just going up and down my keyboard. Right, so let's just recap what's happening there. So what we've got is, so we've gone into there. I'm just going to take that and make that a sine wave. So what we've got is this MIDI to CV. So it's looking at my keyboard, which is, I've got a keyboard in front of me, and it's working out what notes are coming in from MIDI, and it's converting that into a voltage, a control voltage, and it's sending that control voltage to the VCO so it knows what note to play. Right? So note keeps playing. The note hasn't stopped. It's continuous because I've not told it to stop playing. That's why it keeps playing. So how can we stop it from playing? Well, one thing we can do is use this signal here, which is a gate. And a gate tells us, let me bring up another scope. If I take the gate out into input, if I press a button on my keyboard, so it goes high. If I take my finger off the button, let me just bring some sound up. Oh, no, that won't make a difference. Right, if I take my finger off the keyboard, it goes low. Finger down, high, finger off, low. So I could use that. I can use this signal to trigger the audio on or off. And I'm going to do that by using something called the control voltage in the amplifier. So if I go from gate to control voltage and then bring my volume up, now I should really have a keyboard working. Yeah, it's all monophonic, but that's it. Right. Fabulous. We're getting there. No mistakes yet. I guarantee I'm going to get totally lost during this lecture because I'm doing all this from memory. Right. So the next thing I want to do is look at something called an ADSR which is an envelope. And again, this is important for Ableton that we understand these principles. Now, see how sharp that is? It's like boom, full on, off. There's no warmth to it really, or there's no sort of slowness and decay to it. So let's have a look at how we can look at how that might work. But before we do that, we need to understand the principles of ADSR. So let's have a look at ADSR, an ADSR envelope. And you'll see this in Ableton quite a lot. And it's important that we know what it is. An ADSR is an envelope. It's called an envelope. And on the left, we've got amplitude, but this could be voltage. So in essence, it's actually going to be voltage that controls amplitude. So it's voltage that controls loudness. And at the bottom, we've got time. And this whole thing starts when I press a key. So remember that that gate goes high. So as soon as that gate goes high, we can start this envelope. And we've got three elements, ADSR, attack, decay, sustain, and release. Now then, the attack here is how much time is it before we go to our maximum amplitude in milliseconds. All right. So if that's very quick, then it's going to be a sharp attack. Yeah. And then if you've got, if you think of like a cymbal, if you hit the cymbal, it's very sharp. It doesn't come in softly like a bow might on a violin. It comes in very, very quick. Then you've got a decay, which is how long does it take us to go down to this sustain level? So this is in time. Decay is in time, but sustain is an amount. And this is when you've got your finger on the button on the keyboard, on the note. So as long as I've got my finger on the note, it will play this sustain level, whatever that sustain level is. And then when I let go, we've got our release. And that's how long does it take us to go from the sustain level to zero, to silence, right? And that's what we can use here. So let's see if we can get that working. So what I'm going to do is I'm going to add in an ADSR. Now this is really cool because in this latest version of VCV, they're actually drawing the envelope up here. So here you've got your attack, your decay. So here's my attack, my decay, my sustain, and my release times. Right, so let's just listen at the moment what we've got on the keyboard. Right, and then what I'm going to do is I'm going to take this gate, and instead of going into the VCV, so that's basically on, off, I'm going to put that into here. You see how it started playing it because it doesn't know it shouldn't be playing it. And then I'm going to take the envelope out and put it in here. Now when I play, I will be using this ADSR envelope, which will give me a much softer introduction to the sound, decay, sustain, and magenta release. Yeah. And I could change it. So if I want a really long release, let's just really exaggerate it. If I press a note, and if I take my finger off the note, still playing. It's going to play for 10 seconds. Yeah. So you can see how you can play around with this data. Equally, I could do a really quick release. Right, so fabulous. Right, so that's ADSR covered. Let's look at, I think the next thing I wanted to talk to you about will probably be some sort of sequencer. Right, so let's move away from, let's delete this one here. And another really cool thing you can do in VCV, if you press the control key, you can shove them along like that. Right, so if I right click, I'm going to add a sequencer. So there's one there, sequencer. And if you remember, a sequencer is basically going to be sending out signals of what notes to play and any other information that we might want. So what I'm going to do is I'm just going to, see you've got 3 rows here. I'm only going to use the first row, and that first row I'm going to use as a note to play. So what I'm going to do is I'm just going to put some random notes in here, random voltages, and then I'm going to take this here, control volt 1, and I'm going to put that into voltage octave. Okay, and let's have a look. So that's there. And let's set the trigger and put it into gate. Okay, so that's firing there. Okay, so these are just all random. These are all just random notes that are playing, which is from here. And I can change the tempo. And I can change what the notes that are being played by just modifying these parameters here. But it's all out of tune. So what I'm going to use is I'm going to use something called a quantizer. And the quantizer, and again you'll get this in Ableton, is going to force it. There's one there. Right, so the quantizer is basically going to force it to be a certain note. So if I put that control voltage, if instead of going straight to the voltage controlled oscillator, if I go into here and then I take the output into here, and then bring the volume up. This keeps catching me out. Right, we're still playing the same notes, but if you look at this funny thing here, I just did the control key in my mouse wheel. If you look to the right, if you like rotated it by 90 degrees clockwise, you've got a piano. So if I take, so these are my black keys. Yeah, C sharp, D sharp, F sharp, G sharp, and A sharp. So if I take those out, which I've just done, that means it won't play them. And that means we're in the key of C, because there's sharps or flats in C. So now, we've got some random notes playing, or ones that I've put in here, that are all playing together. It doesn't matter what I do here. It's all going to be playing in that key. Okay, great. Right, so let me just turn that mix down there. Right, the next thing I want to talk to you about is something called, I think the next thing I want to talk to you about is going to be pulse width modulation. Is that on my to-do list next? I think it must be. Right, so we've done sequences. Right, so this sequencer, just to recap, is basically this top dial here is all basically voltages, which is control voltage 1 is this top row, control voltage 2 is this second row, control voltage 3 is this third row. And I am sending out those voltages into this quantizer, which is forced into, the grey notes means we're not going to play those. So if it hit one of those notes, it's going to go either way, either to the right or to the left, depending on the value. And then we're going from there into voltage per octave, which is what gives us our note. Right, let's just come down here into a bit of blank space. Let's get another voltage controlled oscillator. And let's get a scope. And let's put a square wave into our scope. Click trigger. Right, there's a square wave. Now, something called pulse width modulation. So a square wave is that, it's a square wave, right? And it looks slightly off square because we're simulating analog here. If you're doing this purely on the computer and digital, you could simulate a perfect square wave. But because VCV is simulating analog, we've got these certain characteristics, these analog characteristics, which is what gives the beauty of analog sound. Now, if I change this pulse width modulation, you see how it's modulating the width of the square. Pulse width modulation, that's what this is doing. And that has a certain sonic characteristic. So if I take, if I take the out, if I press the control key and click here and go up the way and go into my mixer, no, into here. Now if I come down here and if I just modulate that, you'll hear the difference. Right, so you can hear the difference in sound. So that's what pulse width modulation is. But I can't sit here all day doing this. So you should know from your Ableton experience now, you should say, but there is such a thing as a low frequency oscillator. Let's use that. LFO. LFO, where are you? LFO. 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 There we are. LFO. Right. a low frequency oscillator. So this is generating oscillations at a low frequency, surprise, surprise. And it's so low that I can't really hear it. But the frequencies are useful enough for us to be able to control other parameters, as we've already done in Ableton. Yeah, do you remember we were using an LFO to control from memory, I think we did a cutoff in a filter. So let me just put a scope up just so you know what's going on here. Right, so if I take a sine wave and put it in here, you can see the sine wave. Right, and then if let's come out here a bit more. Right, so what I'm going to do now is I'm going to send this sine wave to PWM, which means pulse width modulation. Now nothing's happening yet because I need to modify this little switch here, which gives me basically how much control I'm going to take from this sine wave to modulate that pulse width. Right, so let's try that. And you should see it graphically. There we go, very subtle. So let's just come back up, and so we can turn this mixer back up so I can hear it. There we go. So that's our pulse width modulation. Right, so let's delete all that. Now we understand what pulse width modulation is. Let's modify our sound here. So we've got pulse width modulation. So the first thing I want to do is I want to move my sound to I don't know if I've got the right levels for you guys, I'm just guessing. Let's have a square wave. And then let's put in a LFO. Let's take a sine wave and go to our pulse width modulation. And then let's start to hear that. Much more interesting. Right, so there we have it. So we have looked at pulse width modulation, and we've looked at the low frequency oscillators. So let me just see what's next. So let's see if we can use our knowledge now to generate a beat, some sort of rhythm. So let's just scroll down here, and let's just put this out of the way here. Right, let's get another sequencer. And we're going to need a voltage controlled oscillator, because let's try and make a kick drum. So we've got VCO there. Let me think about this. Right, what I'm going to do is I'm going to take my square wave and put it into here. Right, we're going to turn that sound into a kick drum. Hopefully, if I can remember how to do it. Right, so the next thing I want to do is put an envelope on. Just turn that down in case it's annoying you, which it will be. So let's use the envelope here to control that. Now it's off, right, which is good. So the next thing I need to do is you see how this is ticking through? 1, 2, 3, 4, 5, 6, 7, 8, 1. Let's try and use that trigger to fire this gate. Let's bring that back up. Let's just play with we have a beat. So just shorten my attack. Let's reduce the frequency to try and get more of a kick. I don't know what frequency you can get over Zoom, but let's try something like that. Okay, so the next problem I've got is that. So basically, I've really tightened up that envelope. But if I listen to my music, it's all out of time. So what we need to do is we kind of need to sync these up, and we need to sync up the tempos. So let me just double click this. I think what I'm going to do is come over here. I'm just going to add in a low frequency oscillator, and I'm going to take a square wave, and I'm going to say that's my click. So if I go into here, and then if I take the same signal and go into here, what it should be doing is, yes, that's working. Right, so what I've done now is that I've got this square wave, which is on, off, which is like a click. And I'm telling it to start this, I'm giving the sequences the timing. I think you can maybe use tempo here, but that's the way I'm going to do it, using click there. But the problem is these sequences are still out of time. Now, you see this sequencer here, it's just running through 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, etc., etc. It's running through it there. What that means is every time it gets to here, it's triggering. These are all triggers. So I can take that trigger and I can use that to reset this one. So now when the sequencer gets to here, it flashes, which causes this one to reset. And now 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They're in sync. Fabulous. Right, so now if I just turn these up, we should have something that's in time. And if I increase this low frequency oscillator here, let's try and make some sort of drum with white noise, like a snare sound. So let me just kill these two. So with the kick drum, I used a triangle wave. And with this snare sound, I'm going to use white noise, which is as opposed to pink noise, which varies depending, the amplitude varies depending on the frequency. So let's look for noise, there's noise. Right, so here's noise. And if I get another ADSR, Oh, and I'm going to need another sequencer. Right. So what I'm going to do is I'm going to take this white noise and I'm going to put this white noise, whit is short for white, guess, and I'm going to go into in. Right, that's going to become my snare. So let's come down here and let's take the envelope out and put it into the control voltage here. So remember that control voltage 3 is controlling that white noise. If you're feeling a bit lost, don't worry, you can re-watch this. And you're not assessed on this, but the important thing here is that we're learning some key components about electronic music. Right then, so the next thing I want to do is I'm going to take the trigger from my sequencer and use that as my gate. And then I'm just going to... Oh, look, that sounds snare-esque already. Nice and tight. Let's make that kick drum tight as well. See that? What we just managed to do? Just with white noise. Right, so the other thing is, these, I can turn these on and off. So this sequence is going 4, 5, 6, 7, 8, 1, and it's playing it on every beat. If I press this, I can program it. So what we could do is we have that on every beat, and I could just program this one to be slightly different, like that. And that's the kick drum here. But don't forget, we need to, we've got this LFO on the left as our timing, so I'm going to take that and I'm going to put that into click. And when we get our 1 from here, we're going to reset this. So hopefully, yep, these are now in sync. I just make that a little bit tighter. Oh, that's nice. Right, let's bring our kick back in. Still sounds quite electronic-y. And then let's bring in our notes. Let's increase the frequency, tempo. So that is VCV. What we've got here is the basic components of modular synthesizers. What you can do is you could watch that again and just build it up from scratch. Right, we'll leave that running. So one thing I wanted to talk to you about was just to give you a very quick overview of any questions on VCV first. Just pop it in the chat if there's any questions, or you can use your microphone. It's very easy to get lost, as you can imagine, especially for me teaching it at this end. Right? If you get one thing wrong, it can all unravel because it can become like spaghetti. Okay, I can't see any questions, so I'm going to move on. And if a question comes in, it's fine. We can move on to the chat. Right, so let's move onto here. Just try and get a better view. Right, this is the same thing. This is exactly the same thing as what we've just looked at, right? Let me just get rid of everything. The only difference is this is analog. This is an analog system, right? So what we've got here is we've got a voltage-controlled oscillator, a filter, an amplifier, and an envelope generator. Down here we've got something which enables me to communicate with my computer. Got some drum simulation here, bit of logic. This is all a sequencer, and this is called a wavetable. A wavetable here, right? So we won't go into this in too much detail, but I just want to show you some basics. So if I put this, that's a square wave. So if I put that square wave into, for example, let's just go straight into, we'll go into this one, into here. And if I take my output from here, and go into my amplifier. Okay, and then if I go through, what should we do next? Let's go from the modulation. The other thing I could do is this is a dual oscillator, so I could take another one and put that in. And I've got two playing, got that drone effect. I just kill my pulse width modulation because I need to tune these up. Oscillating away there in the background. Just so what's happening is the amplifier's coming out into something called expert sleepers, and then from there I'm able to get that into my audio engine. So the other thing I can do is just use the sequencer here, and what I can do is I can basically say to it, right, let's take control voltage as 1, and that is like my voltage control, my volt per octave. I can put that into here, and then if I bring that back up again, I'll press play. And if I can drop it down an octave, if I can remember how to do that. Shifting. And shift goes down an octave, I think. Now the other thing I can do is I can take a trigger. Let's say I use CV2, so this is channel, let's use channel 2. I'm just going to go to, let's turn that one off, go to mod, or how do I do that? Is it set up on mod? I can't remember, I think it's set up on mod. That's it, and if I go along here, I can use a trigger, and then I can program a trigger, a beat in, so let's put a beat on every first get a cable, and then let's take the modulation from track 2, which is now basically an on-off. I'm going to go into trigger 1 on this drum, and I'm going to take the output of that and go into here. I don't know if that's going to work. Let's have a look. Yeah, that works. Right, and then let's have a different drum. So let's do that actually. Okay, and then if I go to here, I can program that one drum. And then I can say, okay, let's have a snare on the next one. So go to that, channel 3, and I could just program all of them. And then if I take another output from trigger 2, good job I had my coffee this morning because I would not be able to do this otherwise. Let's put that into here. Let's program that to trigger 2. That's channel 3. What have I done wrong there? That's wrong. Spoke too soon. Right, I want channel 3 modulation out. Oh, there we go. Right, and then let's in a week and I'll still be playing around with that. Right, I have not seen any of these questions, so let me have a look at some of these questions that are in. Okay, so Lewis is asking, how do you get the analyzer? I have set up everything from the spectrum analyzer. This one here, okay, that's not a, right, good question. Right, when you get set up in VCV Rack, what you need to do is set yourself up with an account. Yeah, and then you can go to the web page and choose these different companies. So if you look at like the FACO here, these are really good emulations of their hardware. So these are just like the real thing. These are just like the real thing. So basically, Lewis, you need to go to the web page, create an account, and then that one was, I mean, there'll be lots of different ones that offer it, but the company that did that one, I can't remember which one it was. Was it? Wasn't Valley. I did this earlier, didn't I? I should have remembered which one it was. Let's just go up. It's not that one. Whoops, it's not Impromptu. It's not E-Series. It's that one. So it's BOG, AUDIO, and it's the analyzer down here. Yeah. Okay, and Beth says, I can see what's addictive. Yeah, it is addictive. And you always want to get more modules. But there's a great what's the word, community out there in this sort of thing. There really is, and everyone's interested in it, everyone's playing it. And you can, it has a good, I've invested a lot of my time and money in this equipment here, but it's got a good resale value. I'm not going to lose money on it if you get good stuff. Another good way to start is this one down here, which is the Arturia. Remember, I'm always talking about Arturia. I think they make great products. They do the keyboards here and stuff, which are fantastic. So that's the Arturia down at the bottom is a little bit simpler to understand because a lot of it's pre-wired. But have a go with the VCV. Have a go with the VCV rack and see where you go. I mean, you can still generate really good sounds from there. Matt, it's not too expensive at all. No, it's not massively expensive. Let me just see if I go to Task Manager. There we go. 218 megabytes of memory is all it's using. Yeah. Have a go, have a play. It's good fun. It's free. Download it. You understand a lot of the concepts. I will upload this lecture as soon as I can, probably tonight or tomorrow morning, and you'll be able to just go through it step by step because it is complicated. And if you look at it, if someone came into the end of that lecture and was watching what we were doing here on the screen, or rather, I've just realised I've not actually been showing the screen when I've just been doing stuff. 218 megabytes, Matthew, because I just brought up the Process Task Manager, and I can see how expensive it is. Rack, 218 meg of memory. It's only using 1%, 2% of my CPU, so it's no problem at all. And it's free, so download it, download the plugins, download these, this analyzer's good so you can see what's going on, and just go through the lecture step by step and try and get a basic tune out of it. You can also, if you haven't got a keyboard, I mean, you can use a sequencer, which is what I've done here. Or if you wanted to, you could, if you want to use your keyboard as a musical keyboard, then you can just add in, I want MIDI to CV, which is that one, and then you just set that to computer keyboard here, and then that will work. Okay, and then obviously you've got the same controls, so you set that here to keyboard, and then you've got your voltage, octave, and your gate, which is all you really need to use. Okay, I think that's it. Hope that was a fun lecture for you. It was for me. Probably the highlight of my week, playing with this stuff. Any other questions from anybody? Remember to try and get your project or any work that you're doing in Ableton uploaded onto the site today or tomorrow. Don't forget to do the collect all and save, yeah, because if you're using any bits that I haven't got access to, it won't run on my computer. So this is a good time for you to practice the collect all and save, and then zip up that directory. Okay. Any other questions from anyone? That's fine. That's fine. Yeah, no problem. Yeah, no bother. That's fine. No problem. Any questions from anyone else? No? Have a wonderful weekend, everyone. Sun is shining. Enjoy.